Good day, students. It's been a while, and how you guys doing? I hope you are studying very well. And you're welcome to our online physics class, Staff Secondary School, FUTA. Today we are going to be looking at work energy and power, like a revision of the work that we have done before. Work energy and power. I hope you still remember. Now, these are the objectives that what we're going to be treating in this work energy and power. We have to define work energy and power. We have to calculate the forms of energy by using formulas of kinetic energy and potential energy. Then we have to state the principle of conservation of energy. We have described conversion of energy from one form to the other. Then, and how to apply the concept and formula of work energy and power in solving the related problems, questions. Then we have to calculate, I will show you how to calculate the efficiency of mechanical system in work energy and power. Now, to start with, looking at the picture below, we have a picture of a man in figure A and figure B. The man in figure A is actually pushing a stationary wall, a wall that cannot move. No matter how much force is applied to this wall, the wall will not move. So it's like pushing a stationary wall. While the man in figure B is pushing a bus, a very big bus, and is actually covering a particular distance in the direction of the force. So if I should ask you which of these guys in picture A and B is actually doing more work, your opinion? Well, as you can see, the man in figure B is doing more work, while the man in figure A is not doing any work at all. I will show you why. Let's go on to the definition. Here we have work. Work is defined as a product of net force acting on a body and the distance moved in the direction of the force. As you can see, work is equal to force multiplied by the parallel distance. That means without distance covered, work cannot be done, because work is the product of force and parallel distance. That means that in this first figure, the picture of the man in figure B has done work because it's covering a particular distance in the direction of the force. You can see, look at the arrows of the force of that the man here is doing more work, while this man is doing nothing. Now let's move on with so looking at the unit, the SI unit of work is joules, or kilogram meters square per second square, as you can see. Now, only the component of the force applied in the direction of the motion of the lawnmower is used to do work on the lawnmower, as you can see. Now, I need you to practice these questions. It's a revision topic, so I'm going to leave these questions, these practice questions, for you to solve. The first one: an object is moved with a force of 15 Newton across a horizontal surface. How much work is done if the object is moved 50 meters? Here we are given the force and the distance covered, so we have to calculate the work done. The second question, we have 650 joule of work done. Work is done in moving a desk a horizontal distance of 5 meters. Here we are given the amount of work done and the distance covered, and we have to calculate how much force is used to move the desk. Question 3: how much work is done in lifting a 10 kg box 1.5 meter off the floor? Please practice these questions and I need your feedback. Now, and let's look at these questions together. How much work is done in lifting a 10 kg box? As you can see, the picture of the man in red here is lifting a 10 kg box through a height of 1.5 meter off the floor. So how much work is done? If you look at this very well, don't forget force is a product of mass multiplied by acceleration. Force is the product of mass multiplied by acceleration, and it's also very related to weight, which is equal to mass multiplied by the acceleration due to gravity. And here we are given the 10 kg multiplied by, which is the mass. 10 kg is the mass. And don't forget, acceleration due to gravity is a constant, which is 9.8 meter per second square given there, or it can be sometimes referred to as 10 meter per second square. And if you multiply that through, our weight is going to be 98 Newton, which is approximately 100. So calculating work done now is going to be that 100, which is 98, we approximate it to be 100, multiplied by the distance covered, which is 1.5 meter. That means our answer is going to be 150 joules. 150 joules. That's the amount of work done by the man lifting 10 kg bus 1.5 meter off the floor. Now let's move on. I need you to practice this question also. I need your feedback. That makes it the fourth question. And I also need you to practice this fill in the gap. Here we are in the first one, A. We have a force of 150, a distance of 25. What is the work done? This first one, that means we're going to multiply through by 150 multiplied by 25. And I need you to solve the questions. Solve all the questions here. And moving on to the next part of the series, which is energy. Energy is defined as the ability to do work. Energy is defined as the ability to do work. Ability or capability to do work. And here we have energy is defined as the capability to do work. And the SI unit of energy is also joules, just like we have it in work. The SI unit of energy is also joules. And these are the forms of energy that we have. We have the common forms. Here we have kinetic and potential, which is actually belong to a class called mechanical energy. We also have electrical energy, chemical, and solar nuclear energy. These are the forms of common forms of energy. Of course, we have there are more. And let's move on.